So in our third example, we're going to take a look at a more complicated problem that has addition and subtraction, but it's also more complicated because things can reduce more than they did in the first two examples. I kind of hinted at it in the previous examples, but now we're going to look at a problem that actually does reduce after we find the least common denominator and simplify it. So looking at this elementary school problem here, 49 is 7 times 7. So both of these are missing the extra 7. And yeah, you can actually use the same thing twice. That won't happen in high school, most likely with expressions, but it happens sometimes in elementary school. And so we're going to rewrite this. This won't change. This will be 14 over 49. However, this one right here is now going to change to 21 over 49. And this one right here will change to negative, because it's a minus, negative 14 over 49. And in fact, you can immediately see, because they're integers, that these will cancel out, right? This and this cancel, leaving us with 21 49ths. So not only did something reduce while I was working with the common denominators and then the numerators, but this also reduces. Remember, the way that we would reduce this is we would ask ourselves, is there a common multiplication fact in the top and the bottom? And right, as you can see, the top would be 3 times 7, and we already knew that the bottom was 7 times 7. So this problem not only adds together, but it also reduces at the end to 3/7. And there's no way to know that at the beginning. I mean, I guess you could have reduced 14 49th and then had a bunch of 7s and then have to reduce it. But the best way to do it is to go through the problem and reduce it one step at a time. And so that also can happen when you do algebra. So over here, we have this one that we've seen a couple of times where we're trying to factor this way. The middle term is 0x, so we want to use 7 times 7 so that the problem will factor in the two equivalent factors, 1 plus and 1 minus, to produce the middle term of 0. So they're both going to be 7. They're not identical twin factors, though, because one has to be positive and one has to be negative in order to get 0 in the middle. And as you can see, that's actually what we have over here. This is a common occurrence as the problems get more complicated, that you simply multiply these two to get that. And what that's saying is that this one is missing the x plus 7 from the common denominator over here, right? X plus 7. I need to put it on the numerator. Don't forget, whatever you do to the denominator, you have to do to the numerator. And then this one's missing the x minus 7, right? And so I'm going to put that here and that there. Again, the reason you do it on the top and the bottom is they actually would produce a product of 1, and 1 does not change the answer of a problem. So now we have three expressions that have the same denominator, right? So the first one, the second one, and the original one all have a common denominator of x plus 7, x minus 7. And yeah, it's a little frustrating to have to write it out 3 times, but I found that the students who do take the time to actually write it out and don't try to make shortcuts, they're the ones that don't get lost in the problem or get confused about what they're doing. So even though it takes, 20 seconds or whatever, it's 20 seconds of well-invested understanding. So then here I just have to distribute. Sometimes you'll have to FOIL or box, but here we just have to distribute. So we get x squared plus 7x. Don't forget to distribute the x to both terms. Here I have x squared minus 7x. Notice I'm leaving the negative alone. We'll deal with that in a separate step. It's very important that you leave it alone. Otherwise you'll get confused and you might distribute the negative twice. So just make it x squared minus 7x, and we'll deal with the negative in the next step. And the 98 didn't change because it had the LCD. So don't forget, the LCD is sometimes asked, and you can see it very clearly here. The LCD is all throughout all of this. It would be x plus 7, x minus 7. But the question is, what would the LCD be over here? Well, we reduced it to this. The LCD was originally 49. Just keep that in mind, that the LCD is what you have originally. That's going to be important in this problem because something is going to reduce. So my next step is to distribute, right? I distribute this, and like I mentioned in the previous example, you're going to write right above it, this is negative x squared plus 7x, and then you are going to scratch out the original problem as a good habit so you don't accidentally look at it and think you combine something and recombine it and just make a mistake because you're confused. So scratch it out so you don't look at it anymore. So my common denominator is x plus 7 and x minus 7. And then my numerator would be to add together my x squared here, my x squared here, and then my minus x squared, which cancels, just like over here we cancel out the 14s. Then I move to my next like term. My next like term would be the 7x and the 7x. You might say, well, how did I get the same thing twice? Well, remember, I distributed the negative, so it became positive, so I now have 14x. And then there's only one constant, that's 98, so I'll put that here. And then, of course, we need to talk about domain restrictions, and the domain restrictions are found by setting both of these not equal to 0. I like to call them anti-solutions or anti-roots. And so if I set both those not equal to 0, I would get my domain restrictions would be that x could not equal the first one negative 7, the second one positive 7, so we can just say plus or minus 7. So the problem is I'm not done with this problem. Just like here when I got 21/49, this problem has a GCF, and the GCF is actually 14. So if I take out the 14 from here and from here, just like we did way back in Unit 1, if I take that 14 out, I'm going to be left with an expression of x plus 7. Again, you're dividing 14x by 14, you get 1. You divide 98 by 14, you get 7. But my denominator is x plus 7 and then x minus 7. Again, I still have these domain restrictions. They don't cancel out. They don't go anywhere. They're always part of the answer. So what do? Well, we have to cancel out, right? We have to cancel out this term. We've been learning for a while that whatever you have, if you have something the same on the numerator and denominator, that it reduces by canceling. And that's exactly what we started with when we started rational expressions. You know, we started by factoring and canceling a like term. So the answer turns out to be 14 over x minus 7. The domain restrictions do not reduce. And again, we're going to talk more about what these domain restrictions are when we do graphing. The domain restrictions that cancel like this, they still exist, but they have a different name than the ones that stay. Let me say that again. The domain restrictions are plus and minus 7, but when we do graphing, we'll learn that the negative 7 domain restriction has a different name than the positive 7 domain restriction, and that only makes sense with graphs. So I'm just kind of giving you a prelude to that happening later in the chapter.